Similarity of Triangles practice questions, Euclidean geometry. So this is the question. Okay, question 10.1. You are given the following diagram. Okay, you can read the question. Okay, so give reasons for the statements below. Complete the table on diagram sheet 6. Okay, so let angle R4 equal to x and angle R2 equal to y. So you have the statement and you have to give the reasons. So 10.1.1, you have angle T3 is equal to x, y. Give the reason. Okay, angle T3, this angle. Okay, y is this angle equal to x. Give the reason. So you can see if you use this circle, the small circle, you have a tangent. The tangent xry, okay, xry is a tangent to the small circle at r, and the tangent xry is also a tangent to the big circle at r. So using the small circle and using the code WR, this code with the tangent, you have this angle between them. So you have this angle is equal to x as well. So you are going to say tangent and code, then code theorem. Okay, then code theorem. This is the reason. Now y is angle P1 equal to x. Okay, y is this angle, y is this angle equal to x. Okay, angle P1. So again, if you use the big circle, using the big circle, you have this code SR with the tangent. You have this angle between the tangent and the code SR. So this angle is equal to the angle in the alternate segment. So this angle is equal to x using then code theorem. Now you are given this statement: y is WT parallel to SP. Okay, so y, this line, okay, the line WT is parallel to the line SP. Why? Give the reason. Okay, so if this angle, let me show you. If this angle is equal to this angle, then the two lines are parallel because you are going to have the F shape. Okay, F shape. Let me show you. You have the F shape. Okay, or if this angle is equal to this angle, then the two lines are parallel. Again, you are going to have the F shape. Let me show you. F shape. Okay, can you see F shape? Please check lesson 4 of 25. You are going to learn about parallel lines. So if this angle is equal to this angle, then the two lines are parallel. So we can use these two angles because this is simple. Okay, so let me erase this. We can use these two angles because this is simple. You can see angle T3 is equal to x, angle P1 is equal to x. So you can see the two angles are equal. They are both equal to x. So these are corresponding angles, equal corresponding angles, or you can say corresponding angles equal. Now question 10.1.4. Okay. Ten point 1.4. Y is the angle S1 equal to y. Okay. Y, this angle is equal to y. You can see if you consider this chord, you can see the chord PQ. Okay, the chord PQ is subtending this angle, the angle y. You can see. Okay. PQ is subtending the angle y at the circumference, and this angle S1 is also subtended by the chord PQ. You can see. Okay, you can see. So this angle is equal to y as well because they are both subtended by the same chord or the same arc. So angle S1 is equal to y. You are going to say the reason is angles in the same segment, or you can say angles subtended by chord PQ. Okay, they are both equal to y. Now y is the angle T2 equal to y. T2, this angle. Y is this angle equal to y. So you have the line WT is parallel to the line SP. Okay, let me show you. The line WT is parallel to the line SP. Okay, so you have your alternate angles. You have the N shape or Z shape. Okay, please check lesson 4 of 25. So this angle is equal to this angle. Angle S1 is equal to y. So angle T2 is equal to y as well. You have the N shape or Z shape. Okay, can you see? You have this N or Z. This line is parallel to this line. So you are going to say alternate angles. You have to mention the two lines that are parallel. So you have line WT parallel to the line SP. Okay, so you have alternate angles. Okay, let's move on. Now question 10.2. Okay, 10.2. Prove that RT is equal to WR times RP over RS 2 max. Okay, to solve this question, you need to have an idea of which triangle you are working with. So you have RT. R T, and you have W R, and you have RP, and you have RS, So, can you see? You have your triangle because you have a line WT parallel to one side of the triangle. You can use the proportionality theorem. So, WT is parallel to SP. This was proven in question 10.1. So, let's write the proportionality theorem. Okay, so you have this small portion over the entire side. Okay, over the entire side. So you have RW over RS equal to small portion over the entire side. Okay, so RT over RP, this is equal to TW over PS. You need RT, WR, RP, RS. Okay, so WR, RS, RT, RP. So you are going to use this part only. Okay, always write the reason. The reason why you can write this equation is because you have used the proportionality theorem, and the proportionality theorem is always possible when you have a line parallel to one side of the triangle. So this is the reason, or you can say you have a line parallel to one side of the triangle. So RT is equal to, you multiply by RP on both sides. You are going to have RW times RP over RS. An alternative method to solve this question is to use the similarity of triangles. Okay, you have two triangles. Okay, this triangle, okay, triangle RTW and triangle RPS. Okay, RTW and RPS. So you have to show that triangles in one triangle are equal to triangles in another triangle. Okay, so you have angle R3 is common in both triangles. Okay, and this angle is equal to this angle. Okay, this was proven. This angle is equal to x, and this angle is equal to x. Okay, this was proven in question 10.1. Automatically, the third angle in one triangle is equal to the third angle in another triangle. Okay, so triangle RTW is similar to triangle RPS. Okay, so always respect the order so that you can write the proportionality equation correctly. So the angle at R in this triangle is equal to the angle at R in another triangle. Okay, you have angle R3 in one triangle is equal to angle R3 in another triangle. This is a common angle, and you have angle at T in one triangle is equal to angle at P in another triangle. Okay, angle T3 is equal to angle P1. Okay, T and P, and angle W2. Okay, angle W2 is equal to this angle. Okay, angle at S. Okay, always respect the order so that you write the proportionality equation correctly. So we have used the similarity property angle, angle, angle. Okay, so now let's write the proportionality equation. So you are going to use first and second letter in this triangle over first and second letter in another triangle. Okay, so you have RT over RP equal to first and third over first and third. Okay, RW over RS equal to now second and third over second and third. Okay, TW over PS. Okay, so now you need RT, you have RT, you need WR, you need RP, you have RP, you need RS. Okay, so you are going to use this part. Okay, this part. Okay, so you need RT, you are going to multiply by RP on both sides. Okay, so always write the reason why do you write this equation, because these triangles are similar. Okay, or you can write similar triangles, or you can write you have corresponding sides in proportion. Okay, whenever you have similar triangles, the corresponding sides are in proportion. This is the most used. Okay, this one you can use, this one, the one which is used the most. Now we are going to use this part. RT is equal to RW times RP over RS. Okay, so please check lesson 18 of 25 to learn about similarity of triangles, and lesson 20 of 25 to learn about the proportionality theorem. Okay, so we are done with question 10.2. Okay, let's move on. Now 10.3, okay. Identify with reasons another two angles equal to y. 4 marks. Okay, so let's get the angles that we know. We know this angle is equal to y using this angle, okay, from question 10.1, okay. This angle is y and this angle is equal to y from question 10.1, okay, and this angle is equal to x and this angle is equal to x from question 10.1, okay, remember. Now 10.3, identify with reasons another two angles equal to y. So you can use the small circle. So you have this chord in the big circle is a tangent to the small circle, and you have the chord WT. So you have this angle between the chord and the tangent. So you are going to have another angle in the alternate segment, okay, from the same chord. You have this angle at the circumference from the same chord. So this angle is equal to y, okay. So y is equal to angle T2, and it is equal to angle R3, okay. So this is another angle which is equal to y using TIMECODES theorem, okay. So this angle is y. Now using this angle is subtended by this chord, the chord SP or the arc SP. So you can see the angle Q1 is also subtended by the same chord SP or the same arc SP. The angle Q1 and R3, they are subtended by the same chord or the same arc. So y is equal to angle R3. This is equal to angle Q1. The reason is you have angles in the same segment, okay, angles in the same segment, or you can say angles subtended by chord SP, chord SP. Now question 10.4, prove that the angle Q3 is equal to the angle W2. Let me show you. Prove that this angle is equal to this angle, okay. Q3 and W2. Prove that the two angles are equal, okay. So you can see the angle Q3 is equal to this angle, okay. This angle, this is an exterior angle of a cyclic quad, okay. This is a cyclic quad. So the angle Q3 is equal to the angle PSR, this angle. The reason is exterior angle of a cyclic quad. Now you have angle W2 is equal to this angle because this line is parallel to this line, okay, from question 10.1, remember. So the reason is you have corresponding angles WT parallel to SP, okay. Now you can see angle Q3 is equal to this and angle W2 is equal to this. Automatically the two angles are equal, or the way to prove that the two angles are equal, this angle and this angle, okay, this angle and this angle. So the way to prove that the two angles are equal, you can use another method, okay. You can find this angle, and then you are going to find the angle Q3. Can you see this angle? The angle Q2. The angle Q2 is equal to, can you see? You have this angle P1 is equal to x, and angle Q2 is also equal to x because they are subtended by the same chord SR. Okay, you can follow the lines. Okay, the same chord SR. So angle Q2 is equal to x. The reason is you have angles in the same segment, or you can say angles subtended by chord SR, or you can say 10 chord theorem. So if you don't have this angle, you can find this angle using this angle. So you have a tangent, and this chord SR. So you have this angle between the tangent and the chord. The angle is equal to x. So from this, you have this angle in the alternate segment. Okay, from the same chord, you have this angle. Okay, this angle is x using 10 chord theorem. Now angle Q3. The angle Q3 is equal to 180 minus x plus y. Okay, minus x plus y in bracket. The reason is angles on a straight line. Angle W2, this is an angle in this triangle. You can use this triangle. So to find this angle, you have 180 minus x minus y, or minus x plus y in bracket. Okay, minus x plus y in bracket. The reason for this, you are going to say sum of angles in triangle WRT. Now you can see this angle is equal to this, and this angle is equal to this. So the two angles are equal to the same thing. So therefore angle Q3 is equal to the angle W2. You can see. Okay. Now question 10.5. Okay, 10.5. Prove that triangle RTS is similar to triangle RQP. 3 marks. Okay, let's find the triangles in which we are going to work. Okay, so we need triangle RTS. And you need triangle RQP. Okay, Okay, so you have to prove that the two triangles are similar. Okay, this triangle and this triangle. So to prove that the two triangles are similar, you have to use the similarity property angle, angle, angle. Okay, you have to show that three angles in one triangle are equal to three angles in another triangle. So we are going to work in triangle RTS and triangle RQP. Okay, RTS and RQP. RQP. Okay, these are the two triangles in which we are going to work in. Okay, so this angle is Y, and remember, this angle R3 is Y. This was proven in question 10.3. So you have Y is equal to the angle R2 equal to the angle R3. The reason is, you can say, proven in the previous question. Okay, we carry on. You can see, let me show you. This angle is equal to this angle because the two angles are subtended by this chord RQ. Okay, so angle P2 is equal to the angle S2. These are angles in the same segment. Okay, the reason is angles in the same segment or angles subtended by chord RQ. Okay, this chord is subtending this angle. This chord is subtending this angle. Okay, so this angle in this triangle is equal to this angle in this triangle. Okay, so you have two angles in one triangle equal to two angles in another triangle. Okay, this angle is equal to this angle, and this angle is equal to this angle. Okay, so automatically the third angle in this triangle is equal to the third angle in this triangle. So you have this angle is equal to this angle automatically. So the angle RQP, this angle, okay, RQP is equal to the angle RTS, this angle. The reason you are going to say sum of angles in a triangle. Now you can conclude, therefore, triangle RTS is similar to triangle RQP. So always respect the order. Let me show you. This angle, the angle at R in this triangle, is equal to the angle at R in another triangle. Okay, and this angle at T in this triangle is equal to the angle at Q in another triangle, and this angle at S in this triangle is equal to the angle at P in another triangle. You can see angle at R is equal to angle at R. Okay, R, R. Okay, angle at T is equal to angle at Q. Okay, angle at T equal to angle at Q. Angle at S equal to angle at P. Okay, angle at S equal to angle at P. Always respect the order so that you write the proportionality equation correctly. Okay, so the reason why this triangle is similar to this triangle is the property angle, angle, angle. Or you can write like this, angle, angle, angle. Now, question 10.6. Okay, hence prove that this is equal to this. So you can see, let me erase this. Okay, you have to prove this. Okay, so you need, let me show you. We can use this. Okay, you need WR. You don't have WR. You need RQ. You have RQ. You need RS. You have RS. You need RP. You have RP. Okay, so you don't have WR. Okay, WR. So can you see RQ? RQ goes with RT. Okay, first and second RQ, first and second RT, and you have RT is equal to this, and you have WR inside. You can substitute this, okay, this in the place of RT, since you have RT, and then you are going to have WR. Let's see. So we are going to write the proportionality equation. Okay, using this, you have RT over RQ. Okay, RT over RQ equal to RS over RP. Okay, RS over RP equal to, you can continue if you want. You are going to have equal to TS. Okay, let me show you. You are going to have this equal to TS over QP. Okay, so we don't need TS. We don't have TS. We don't have QP. So we can stop here. So the reason why you can write the proportionality equation is because the two triangles are similar. Or you can say you have similar triangles. Or you can say you have corresponding sides in proportion. Okay, the most used is this. Okay, now we need to have this. You have RS, RS, RP, RP, RQ, RQ. You don't have WR. You have RT. RT is equal to this. We are going to substitute RT. So you are going to have in the place of RT this. Okay, you have this in the place of RT over RQ equal to RS over RP. Now you need to get rid of RS. You are going to multiply by RS in the numerator and you multiply by RS in the denominator. So you multiply by RS, you are going to cancel. Okay, you cancel, you only have WR times RP over, you multiply by RS, you are going to have RQ times RS. This is equal to RS over RP. Can you see? You need RS squared over RP squared. So you can multiply on both sides by RS over RP. On this side, you are going to cancel. So you are going to have WR over RQ equal to, you multiply by RS over RP, you are going to have RS squared over RP squared. Okay, so you have proved. Can you see? Okay, and we are done with this question. Okay. Okay.